Number 10 is going to ask us to write a script for this, and it's going to this series is going to compute a term and it's going to add it up every time like a series would, and until the absolute value of each term to be added is less than 10 to the negative 7. So we're just going to keep adding terms until it becomes smaller than 10 to the negative 7, or until we've added 100 terms. So whichever one comes first. So this sounds like a while loop to me, because we're just going to keep doing something until we reach a certain amount, and we don't know when we're going to do that. So that's the purpose of our while loop. And it says the last term added to the sum, the variable sum, will be the last term whose absolute value is greater than or equal to 10 to the negative 6. So this also confirms that it's a while loop. We're also going to use a counter I, and it's going to help us keep track of how many times we're going to use it. And we're going to use only these variables and arithmetic functions, like no built-in functions. So let's see how we can write this. So let's figure out what our initial I was, because apparently we're initializing all this stuff. So we're just going to do this one right here. So PM3 is equal to negative 27. And I think this is referencing to this part. So this is equal to negative 27. So we have negative 3 to the I plus 2 is equal to negative 27, which is also, we know, is negative 3 cubed. So I is equal to 1 to start off. And it even tells us here I equals 1. So we're making sure there's no mistakes in this. Factorial is equal to 6. That makes us make sure that this is I plus 2. Factorial, which is 3 factorial, which also is 6. So we're making sure all this works. Term, here is going to tell us what the term is. So this is term. And then the sum is just us adding each term. So let's try to start writing down this code. So we're going to write a while loop. So we're going to say while. And it says the absolute value of each term is greater than 10 to the negative 6. So a function for this, this is not within, we're not using inbuilt functions within the while loop, but an inbuilt function to tell us the absolute value is abs. So abs of, and then we'll say term. And then while it is greater than 10 to the negative 6. So while this is still greater than 10 to the negative 6, we're going to keep going. And, so you put two ands, I, which is our counter, is still less than 100. So once this reaches 100, we'll stop. And once this becomes less than or equal to 10 to the negative 6, then we'll also stop. So this is how we write the while loop. And we're just going to keep our running product going. So we have PM3 equals PM3 times, and then negative 3. We got factorial is equal to factorial times, and then I plus 2. And since we have an I plus 2 right here, that means we need to add the next I, right? Because if we did not change I, where I is the number 1, we're just going to add the same number. We don't want to do that. So the first thing you actually have to do here is I is equal to I plus 1. We're going to increment I before we do this. And I just want you to notice that. I wanted to write this so you can see that. Then we have term is equal to PM3 divided by factorial. And that's going to be our actual term, right? And that's going to help us change our term so that every time the while loop goes back, we can see that the term changes. If you never change the condition, the while loop will go infinitely. And then we say sum is equal to sum, which is the old one, plus our new term. And that's how it's going to work. So term, that's it. And you just end your while loop. So if we trace this, we're saying while the absolute value of our term is greater than 10 to the negative 6, and the increment here, so the I, the one that's the counter, is less than 100, we're going to increment I. So we're going to do I equals I plus 1. Then we're going to increase our running product, or increase our factorial. We're going to compute that term, and then we're going to find our sum. And then we want to display, and I'm pretty sure if we want to display I at the very end of this, we can just say I, and that's it. We just have to write I at the end of the script, and that will tell us what the value of I is. And if you want to suppress all these, I would put a semicolon there so that it doesn't show every single thing that happens. And if you also wanted to show your sum, you can say sum, and these are just different lines that you would write, correct? And that's how you do number 10.